Hello, guys. Let's have some fun with balancing chemical equations. So remember that when we are balancing equations, we have to adjust for the coefficients, not the subscripts. And if you have an even odd situation, multiply by 2 to make everything even. Let's take a look at the first example. We have sodium plus Cl2 forming NaCl. So let's count the number of atoms on my reactant side. What is my first reactant? Na, right? I have one sodium atom. How many chlorine atoms do I have? Two, right? What about on my product side? I have one sodium atom. How many chlorine atoms? Only one. So since I have only one chlorine atom on my product side, let's multiply NaCl by 2. So if I do that, now I have 2 sodium atoms and 2 chlorine atoms on my product side. Now I have more of sodium atoms on my product side than in my reactant side. So I have to go back to my reactant side and multiply sodium by 2, right? So if I put a 2 right there, this is going to mean that now I have 2 atoms. Let's check our work. Sodium, 2, 2 on both sides. Chlorine atoms, 2 and 2 on both sides. Okay, this is balanced. Let's take a look at the next example. So here, this is our reactant side and this is our product side. Let's count the types and number of atoms. So my first atom is carbon. How many do I have? One only, right? Then hydrogen. How many do I have? Four, because of this four right here. And then oxygen, I'm going to have two atoms. How about my product side? So carbon, I have only one. Hydrogen, I have two. How about my oxygen? I have two in CO2 and another one in H2O. So a total of three atoms, right? I have to add the two plus the one atom from oxygen. All right, now I see that I have the same number of carbon atoms on both sides, but there is a difference in case of hydrogen and oxygen. So which one do you start balancing? Well, do not start with oxygen atoms because there are actually two products that contain oxygen atoms. Let's start with the easier hydrogen atoms. We have 4 on the reactant side, 2 on the product side. So how do I make 4 on the product side? I multiply water by 2. So 2 times 2 is going to give me 4 hydrogen atoms on the product side. What happened to my oxygen atoms? They changed too, right? I had 2 in CO2 and now I have 1 times 2 in H2O. So 2 in CO2 plus 2 from H2O multiplied by 2 times. That is going to give me 4 oxygen atoms. Awesome. So now my carbon atoms are balanced, my hydrogen atoms are balanced, and my oxygen atoms are not yet. I have less on the reactant side compared to the product side. So what do? I multiply my reactant side by 2 again. 2 times 2 is going to give me 4 oxygen atoms. Let's check our work. Carbon, 1, 1. Hydrogen, 4, 4. Oxygen, 4, 4. Yay, we balanced it. Let's take a look at the next example. So here are my reactants, here are my products. Let's start with the first atom in my reactant side, magnesium. How many magnesium atoms do I have? One, right? Next atom, sulfur. How many sulfur atoms do I have? One again. Oxygen. How many do I have? Two. Okay, so I'm going to keep the same order, magnesium, sulfur, and oxygen. How many magnesium atoms do I have in my product side? One, right? How many sulfur atoms do I have? One again, right here in sulfur dioxide. How many oxygen atoms do I have? Well, I have one in magnesium oxide and two in SO2. So this means that I have a total of 3 oxygen atoms. Okay, so my magnesium and sulfur seems to be balanced so far on both sides, but my oxygen is not. I actually have an even odd situation. So what do? I take a look at the odd side and multiply that by 2. But I have 2 of my products that actually contain oxygen. Which one would you multiply to make it even? Magnesium oxide, right? So I'm gonna put a 2 right there, which is going to also change my number of magnesium atoms on my product side. So now I have 2 magnesium atoms. And how many oxygen atoms do I have? Well, I have 2 from magnesium oxide because I multiplied this by 2, and I still have 2 from SO2. It's going to give me a total of 4. Okay, so now let's go back and check magnesium and sulfur again. Well, my sulfur is still balanced, but not my magnesium anymore. So I have less on the reactant side, so I have to multiply that. So I'm going to multiply magnesium sulfide by 2. This is going to give me 2 magnesium atoms on my reactant side. However, my sulfur atoms also changed by 2 because I multiplied magnesium sulfide. Okay, so what's next? Now I have to go back to my product side because I have less sulfur atoms there. So what do? You multiply SO2 by 2, which is going to give you 2 sulfur atoms. Now I have it even on the both sides. But what happened to my oxygen atoms? I have to multiply that too, right? So 2 times 2 is 4. And I also have 2 more oxygen atoms in magnesium oxide. So that's plus 2 going to give me 6. Okay, let's take a look at the balancing again. So magnesium 2 and 2, that's awesome. Sulfur 2 and 2, awesome. Oxygen 2 and 6. So I have to adjust for the number of oxygens on my reactant side. So I have to multiply O2 by 3 to give me the 6, right? So that is going to be 6, as 2 times 3 is 6. Okay, let's check our work. Magnesium, 2 and 2. Sulfur, 2 and 2. Oxygen, 6 and 6. Okay, awesome. Let's take a look at the next example. So here we have calcium and nitric acid on my reactant side, and hydrogen gas and calcium nitrate on my product side. And here I'm actually working with polyatomic ions. How do I know? Because I have the same atoms bunched together into an ion, in this case, the nitrate ion, NO3 minus. So when I'm balancing a reaction which contains polyatomic ions, I have to treat them as a whole. Let me show you how. Let's start with counting the number of atoms as we usually do. So calcium, how many calcium atoms do I have? 1, right? Then hydrogen, 1 again. And NO3, I'm going to take it as a whole. So NO3, and this is an ion, it actually has a 1 minus sign. So how many do I have of that? 1 only, right? What happens on my product side? So calcium, hydrogen, nitrate ions. How many calcium atoms do I have? 1, right? How many hydrogen atoms do I have? 2. How many nitrate ions do I have? 2 again because I have this 2 down there. So that is 2. Okay, so let's start balancing. Um, let's do the nitrate ions first. So I have 2 here, but only 1 there. So I have to multiply nitric acid by 2, right? HNO3 by 2. If I do this multiplication, then this is going to change for 2. This is going to change for 2. What happens now? Well, let's check our balancing. Calcium atoms, 1 and 1. hydrogen atoms, 2 and 2. Nitrate ions, 2 and 2. Okay, I balanced it. Awesome. Let's take a look at the next example. So I have silver nitrate and sodium sulfate on my reactant side, silver sulfate and sodium nitrate on my product side. And again, I'm working with polyatomic ions. Which are the polyatomic ions? Well, the nitrate ion and the sulfate ion, which I have both on both the reactant and the product side. So let's start counting our atoms and ions. So silver, I have one only. NO3 minus, those are my nitrate ions. On my reactant side, I have one only. Sodium, I have two. Sulfate ions, SO4, 2 minus, is going to be one only, right? Because only have one SO4 there. Okay, how about the product side? So let's copy this over. Silver, NO3 minus, Na, SO4, 2 minus. So silver, I have actually 2 on my product side. How many nitrate ions do I have? One only, right? How many sodium atoms do I have? One. How many sulfate ions do I have? One again. Okay, so if I look on both sides, I see that my silver is off and my sodium is off. So let's start on the top and let's start balancing my silver atoms. Since I only have one on this side, I have to multiply that by 2. So that is going to be 2 silver nitrates. And I adjust for the numbers, so 2 and 2 for the nitrate ion. Okay, now I have the same number of silver atoms, but my nitrate ions are different. So I have to adjust that by 2 on my product side. So that's gonna be 2 for the nitrate ions. And since I adjust the sodium nitrate, I have to put a number 2 next to it also. Okay, let's check our work. Silver, 2, 2. Nitrate ions, 2, 2. Sodium, 2, 2. Sulfate ions, 1, 1. Okay, we balanced it. Let's take a look at one more example. So I have here aluminum sulfate plus calcium hydroxide on my reactant side and aluminum hydroxide and calcium sulfate on my product side. Do I have polyatomic ions? Oh yes, I do. I have sulfate ions on both sides and I have hydroxide ions on both sides. Okay, let's start counting our atoms and ions. So let's start with aluminum. How many aluminum atoms do we have? 2, right? Sulfate ions, SO4, 2 minus. We actually have 3 of that, right? So that's gonna give me a 3. Calcium, we have 1. How many hydroxide ions do we have? 2, right? Okay, let's do the same on the product side. So we start with aluminum, then SO4, 2 minus, then calcium, and then OH minus. Okay, how many aluminum atoms do we have on the product side? 1. How many hydroxide ions? 3. And just be mindful to put it to the right place. Okay, how many calcium atoms? 1. And how many sulfate ions? 1 again. Okay, let's start balancing. Let's start on the top with aluminum. I have 2 on my reactant side, 1 on the product side, so I have to multiply this by 2. If I do that, my aluminum will change for 2, but my hydroxide ions, 2 times 3, also going to change to 6, right? Okay, so let's take a look at the sulfate ions. How many do I have here? So I have 3 and 1. In order to account for that, I have to multiply that by 3 on my product side. right? So now I have 3 of the sulfate ions, but the number of calcium also changed. So that's gonna be 3 also. Okay, so my aluminum and sulfate ions are actually balanced, but my calcium and hydroxide ions are off. Okay, so let's take a look at calcium first. I have 1 here, 3 there. So why don't I just multiply calcium hydroxide by 3? Right? Now my calcium became 3 on the reactant side, same as it was on the product side. What happened to my hydroxide ions? Well, 2 times 3 is also 6, just as on my product side. So 6 and 6, 3 and 3, 3 and 3, 2 and 2. Okay, can you see how much easier it is to balance the equations when you are looking at polyatomic ions as a whole? It is much easier, right? So I hope this is helpful and see you in the next video.